All right, so received a question on exercise 11.2, specifically with regards to the system of differential equations and to whether or not the system of equations was properly set up in the code I received. Okay, and so I'm just going to scroll down here for a second. So you go through the derivation of the equations. Okay, and then the big thing is right here. So equation 11.1 is the second order diffie q of interest. And then we're given two initial conditions, right? So we're told that d theta dt at time equals 0 is 0, and that my initial angle at time equals 0 is theta naught, initial launch angle. And so my hope is that just by looking at the two initial conditions provided, the light goes off that, I need to define an intermediate variable that will allow me to take my second order diffie q and write it as a system of two first orders. So in this case, I would introduce some intermediate variable, call it v theta, whatever you want. So say v is defined as d theta dt, and so that this becomes dv dt plus g over L sine theta is equal to 0, and then you would have that, what would you have? It's harder without a piece of paper. So I'd introduce an intermediate variable so that v is by definition d theta dt. So diffie q1 would be d theta dt is equal to v, diffie q2 would be dv dt plus g over L sine theta is equal to 0, right? Because dv dt is equivalent to d squared theta dt squared. So you have a system of two first order diffie q's. Okay, and so the question was, are the equations properly set up in my code? Okay, so let's take a look. Let's put my head over here, right? Because you might not even need to make this one big. Time, what are we doing here? So time, so that's not going to be right initially. So if I look at your diffie q, remember the second argument's my range of time, but it's going to look for a vector of time 2. Initial time and final time. This is a vector of length 100. Okay, so I could do length space 0, 10, 2 to make it a vector of length 2. But just so it's clear to me, I'm just going to use 0, 10. Okay, so we'll go from initial time of 0 to final time of 10. So I should say I haven't checked any of this. The question was about whether or not the code was set up correctly, so that's all we're going to look at. So they define initial angle, initial velocity, that's good. So it looks like they must have defined some intermediate variable. Then we're going to solve t comma input. And so sure, you could call that input if you want. T will be a vector of the times at which my functions were evaluated. Input here will be a matrix where column 1 will be v, column 2 will be theta as a function of time. Simple pendulum rate. So now time range. Yeah, initial conditions. So that looks fine. So then we chop input apart to get v and theta. Okay, that looks fine. But now let's look here. So my rate function, I could take as an input time. You can call it whatever you want. That's fine. You can call that input if you want. That's fine. Just try not to confuse yourself with time and input up here, right? That it's clear that they're different. But it's ultimately a matter of preference. So G and L. Unpack your inputs to v and theta. Okay, that's fine. So now I just need, let's keep track of this. So v and then theta. Okay, so I think the order, so this is where I might change the notation just to try and keep the order in my head consistent. So we have v and then theta. Okay, so you have d theta squared dt squared. So this is essentially dv dt, my first rate. So look back over here. So that'd be negative g over L times sine theta. Negative g over L times sine theta. Okay, that looks fine. Sine theta, fine. We're using radians, good. And that's L. That's good. So G and L are both scalars, so in theory you don't need that, but that's fine. Then d theta dt, okay, well, that should just be v. So if I go back over here, so the trick should be looking at my two initial conditions is I'm going to define an intermediate variable. And again, I'm sorry I don't have my pad hooked up, but we're going to define an intermediate variable v is equal to d theta dt. So diffie q1 becomes d theta dt is equal to v. Diffie q2, right? So that's the rate of change of theta. Diffie q2, right? D squared theta dt squared is equivalent to dv dt. So dv dt is going to be equal to negative g over L sine theta. All right, and so that's where I get my system of two first orders. So this is essentially dv dt is at negative g over L times sine theta, but then d theta dt will just be equal to v. Okay, all right, yeah. It's just how I'm defining v, right? V in this case is not, the true v, right? It's just the rate of change of theta, but that should be it. Then packing them up. So in your case, you've got d theta dt and then d theta. So the order is just reversed. Okay, so variable 1 is v, variable 2 is theta. So what I want first is the rate of change of v and then rate of change of theta. And so this is where I might rewrite this as dv dt, but we'll stick with your notation. I'm also guessing there's a slight spelling difference here because it's showing that they're not used. Okay, yeah, and that takes care of that. So what I'm going to do is I'm going to delete that. And I'm going to cut it. Okay, so I have rate of change of v. And then rate of change of theta. Okay, this way the order is right. And this is where I might call this dv dt, so it's clear to me that this is rate of change of v, which is my first variable. Okay, but not worrying about anything else. I think that should do it. So this is 11 to 1. Yeah, so it ran. We're not doing anything. So let's I'm going to generate a plot real quick. I'm going to plot, and since I only care about theta, I don't really care about v. I'm going to plot t, which is my vector of times, versus theta. Okay, we'll just create a basic plot. You can improve upon that. Yeah, so now I have the angle in radians as a function of time. Okay, so that's it. So all I did is I flopped the order here, all right, to make sure that the rates were properly matched up, so that this is the rate of change of variable 1, which is v as you're defining it. This is rate of change of variable 2, as you're defining it, which is the rate of change of theta, and that's just matching up with the variable order in which you unpack and then list initial conditions here. Okay, but yeah, that's it. So that was the only real change. So time, yep, change that to just be a vector of length 2. But that's it. Okay. Oh, and then this you originally had an L in there as well. It's just v, and it's just a matter of how you're defining things. If you want to define v as being something else, you could, right? You could define v as say g over L d theta dt, but then that would affect what d squared theta dt squared is in terms of v, right? So you'd have to propagate that throughout. Okay, so cool.